is I'm even going to help some of you on the graphing. I'm pondering the idea of showing you a little trick. I'm trying to figure out if I want to do this though or not, but we'll see. Okay. A couple of things to take note of here. One, the directions that you see in the section here to try and help remind you how to do some things will be there on the test itself. Same directions written the same way. So if that helps, great. Otherwise, any examples that we've done together, any of the note sheets, and a couple of you used them before, those are usable on the test. So you've got lots of things, lots of tools at your disposal to be able to use on that if you so choose. Okay, but for here right now, we're going to get going and drawing 2 lines. So hopefully you grabbed yourself a colored writing utensil from the front, bless you, as we're going to dot ourselves a couple of lines and see where they cross. So like always, my first job is to plot the y-intercept. And that's always going to be this number that's hanging out on the end by itself. Unless we just have x or y equals, but we'll get to some of those. So here, if my y-intercept is 10, stressing y, okay, y is always along this up and down line. So 10, that's kind of high up, kind of squishes in with my 1 here. What number's in front of x in this case? 1, but with the negative there, it'll be like -1. So here, when I go to do my slope, it's -1 over 1, because we always want it to be a fraction. But notice my 1 on the bottom isn't negative. Okay? Whenever I put that over 1 part, it's always a positive. So what directions am I heading?
Down right.
All right. So down 1 and right 1. And I'm going to keep going down and right, and I know it can get to be a bit tedious, especially when the slope is small like this. But it makes it so much easier to find answers. And I don't even have to worry about going the other direction with this one. So I can get that one completely dotted. So then I go back and I do the same thing with the other one. Okay, my y-intercept's at 1. And this time I see the 2, but again, it's not a fraction right now. So I want to put that over 1. So if my slope is 2 over 1, what directions am I going to head this time? Yeah, I'm going to go up 2 and right 1. So up 2 and right 1, up 2 and right, up 2 and right, and I look up and I'm like, okay, so it seems like I've got myself a couple of points that have something in common now. Because as I did my up 2 and right 1, all of a sudden I came upon this guy right here, okay, where 2 dots are actually the same for each line. So that is my answer. So I'm going to write that as a point. Now again, a little different than slope. How many do I go over and then up to get to this point? Okay, right. Right 3 and up 7, so 3, 7 would be my answer. Okay, because the x value always comes first, the y value always comes second. Now, number 2, here comes a twist. Not in the first equation, the second one might get us though. Yep, these are still going to come in. So this is almost going to be like a freebie assignment, because we're going to do a super duper majority of this together. So let's see here. First one, same deal. Which direction am I going to go for my y-intercept? Okay, 1, which is going to be up. So once I go up 1, where am I going to be going from there for my slope? Up 1 and right 2. So up 1 and right 2, just being careful to make sure we're going good. Now this time, I had my slope is up 1 and right 2. If I run out of room and I want to be able to complete my line going the other way, what else could I do for my directions? Absolutely. I could go 1 down and 2 left. Because that way I can get my line going all the way through.
If they don't intercept, what do we do?
No solution. Now here's the one that's tricky. Notice every equation we've had so far has had y and x, y and x, y and x. Well, this one just has x. So again, these work. It says x equals 4. So I go to where x is 4 and I'm going to put a dot. If it's x, it's going up and down. If it's y and a number, though, it would just go sideways. So here, so anywhere along there, my x value is 4. And what you notice here, cross is right there. Okay, yep, right 4 and up 3. So 4, 3 would be my answer for that one. Now, since we're getting into some weird stuff here, I'm actually going to do this first page with you because I threw a little twist in on every one of these. Wasn't a bad idea, though. So as we start to look down at number 3, here's the part that can cause me, at least I think, can cause me a problem. I see this, but I don't see a number at the end. If I don't see a y-intercept at the end, and it does have y and x, what number goes on the end of this? 0. So I'm going to start at 0. And similar to what we did in number 1, my slope is negative 1 over 1. Because that negative in front of the x makes my 1 negative. So down and right. Just because the number on the top's a negative doesn't mean the number on the bottom is. Down and right, down and right. And we're going to dot this all the way to the corner, but then again, just like before, instead of going down and right, if I run out of room, I can go up and left, up and left. I just go all the way to the corner. So I've got myself a real nice line of consisting of nothing but dots. So then to graph my second line, where would I start with my second line? Negative 4. And negative 4 on the y's. That's important. And this one's pretty straightforward. Just up 1 and right 1. Up 1 and there it is. All right. So right there is my point, and I agree. I go right 2 and down 2. So I end up at 2, negative 2. And again on these, the big thing is going to be you've got to show me dots. Because on some things before, some of you just got into guess and check mode until you found 2 numbers because they're all coming out as whole. You've got to work on the graphing part of this. So I got to see some dots somewhere. All right, last one. No weird twists. So here, where do I start? 3. And make sure that my slope is a fraction.
Like if the slopes are the same and the y-intercepts are different, then it's no solution.
Nice, and I like the way that you thought about that. That's a good point. Eric just mentioned, he goes, well, if you see that the slopes are the same, and they are, and you see that the intercepts are different, could you just write no solution, same slope right away? You actually could. As long as you explain to me what's going on, I don't mind. Now, maybe you don't see that right away. And if you don't, we could still go ahead and say, okay, so I'm going up and right. So let's see, the opposite would be down and left. And you'll probably notice fairly quickly once you start making dots for your second line, even though this is perfectly acceptable as long as you tell me they're the same slope, when you start that second one at -4, and then you're going up 3 and right 1, now I'd hope that would trigger something. You're like, wait a minute, this seems like it's the same slope. And you start to make dots, and you're like, I'm kind of noticing these aren't crossing each other anywhere. Well, maybe when I do it the other way. So up 3, so down 3 and left 1. Oh, they don't cross at all. And that way I notice it this time, and that's always going to end up being no solution if they don't cross. But always look at those slopes first, because if they are the same, and they have to be identical, then you could say no solution because they're the same slope. Okay? Basically, again, on the test itself, 4 graphing ones, just like the ones that you see here. So as we turn the page, and yes, even when we get to the test itself, we will have, let me come out a little bit, okay, some help in letting you see how this works. Because again, here, in the example up above, it just says x equals, and whatever's in that box is going in where the x goes. And then I show you how it works out and how I can plug it back in to get the answer. So we're going to do that. But before we start, I want you to go through on problems 5 through 8, find the equation that's just x or y equals, and then something. And I want you to box in the other side of that equation. So if it says y equals, we'll box it in, even if it says x equals, okay? Because that reminds me, that's what I'm going to be substituting in. And like I said, we're going to do a couple of these. On this page, I think we're going to do 5 and 7 for right now. So let's see what we've got working here. All right, so we already found the equation, and it's y equals. So it's going to go in where the y goes, and it's going to replace it. That's why I cross this out most of the time. Because now I know, okay, I have x plus, y is not there anymore, it's what's in the box. So 4x equals 5. So if I combine my x's, how many x's do I have now? 5. 5x equals 5. X equals 1, because that's what happens when I divide by 5 here. But again, this is a system. There's 2 values we need to find. Well, I found x. Yep. So to find y, I just plug in my x value where the x is at. And I've got my 2 values, and I'm done. Okay, so nothing, again, nothing too shabby, nothing really terribly awful. So, you know, just something to kind of consider. Now, will it always just be directly plug in, and that's all I've got to do? There's one other part to this that I've got to pay a little bit of attention to. So like if I get down to 7, I notice it's y equals. Okay, so it's going to go here where the y goes. But there's a 2 in front of it this time. That 2 doesn't go away, just the y does. So we're going to have to distribute. So that 2 times 3x plus 8, because that's what I'm going to plug in. And like Taylor mentioned, if we distribute, that 2 is not only going to go to the 3x, it's also going to times by the 8. So 2 times 3 would be 6x. 2 times 8 is 16. And now I'm ready to go to work on this one. Always want to look for like terms first. So in this case, I could put my x's together. I got to watch signs. They're both positive this time. But if one was positive and one's negative, I got to watch for that. So 5 and 6 is 11. Now what? That's right. Since I'm trying to get the x's alone, I'm going to subtract the 16. And then my last step, of course, is to divide. Close. Okay, don't lose our negative with this one. So it's negative divided by a positive. I end up with a negative out of that. Okay, so I've got -1 for that one. So that's how these work. But always watch to see what that variable in front is, because that's where you're plugging it in. Because like if you went to 8 and you're like, oh, it's y, and you plug it into y, you're not plugging it in the right place, because this is x equals. Okay? But you'll probably know because your variables would be different in that case. So that's what's going on in this section. And if we got some time at the end, we'll come back with 6 and 8. But I want to make sure we get a good solid start in every section here. For which one? Oh, gee. Caught me napping there. I'm like, we didn't do y. What the heck? So yeah. So y is going to be 3 times, I know what x is now, plus 8. So 3 times -1 is -3. So if I owed somebody $3 and I found 8 in my pocket, how far am I going to be ahead when I pay them back? $5. And I get my 5. Now we're actually done with that problem. So when we get away from this, we go away from substitution. We move our way into elimination. Now again, it has an example up there of one where I've got to multiply. And we've got another example of one where I don't have to multiply, where if I just add down, variables go away, and I substitute it. Whereas here, I had to multiply the bottom one by a -2, because I wanted this to be -4 since that's 4. They both work for us, though. Okay, and both of the examples, again, will be sitting there trying to help you out in the test as well. So let's do an example of each type here. So let's say we do 9. If I add straight down, does the variable go away? Or am I going to have to multiply by something? Do I have to? No, because if I add down, -3 and +3 with my y's cancel. So 2x plus 1x is 3x. 14 and -11, watch your signs, it's +3. Like, ooh, that went quick. Yeah, it can. And then just divide by 3. Now, unlike me on the last problem, we're going to remember to do both of these this time. And again, it's personal preference on which equation you want to plug into. Let's just say I happen to plug into the top one just because I'm in a habit. So I've got 2x, but I know what x is now. It's this 1. So I plug that in, and then I just copy the rest of it. Because now you notice the only variable left is y. So I multiply the 2 times the 1. And now I've got to work on solving this equation for y. So how am I going to get that 2 out of there? Okay, -2 minus the 2. Last step. Divide by -3. So some, like 9 and 10, will give you the ability to just add down and cancel out a variable and get the answer. That's always nice, but does that always happen? No. Okay. So for instance, to get a problem working for you where it doesn't just come out nice right away, we'll do a flipperoo here, because I'm sure there are going to be a problem somewhere. Let's say, for instance, we hit up number 14. We'll do a couple of these. So if I look at 14, if I add down right away, I'm still going to end up with x's. I'm still going to end up with y's. Well, that's no good. Now, the only question I have is, does it need to be negative? No, because in this case, this x is already negative. So here, if I do 2 times 2, that'll get me 4x, which is good, because then it'll cancel with the negative 4x. But I got to multiply that 2 all the way through. And then the bottom we just leave alone in this case. And sometimes it may be the top equation I times, sometimes it may be the bottom. It just depends. Because now, I look and I say, okay, 4x and negative 4x, they wipe out. Watch again, signs are critical. 2 and negative 4 is negative 2y. 6 plus negative 8 is negative 2. So is my last step here to add 2y to each side? Just divide, okay? Make sure that negative goes with, and I can get my y. Again, when I go to figure out x now, I can use either equation, but I like to be consistent, so I'm going to use this top one. So I got 2x plus y, but I know what y is. It's 1. So I plug that in here. And again, the colors can help on this. It lets you see what you're substituting in. Equals 3. So the only thing that changed in that first equation is 1 went in for y. How do I work this now as a 2-step equation to figure out what x is? What's my next step here? Yep, minus the 1. And then my last step would be to divide by 2. So again, always do try to add down first to see if a variable disappears. But if it doesn't, don't let that bother you. So let's see here. Let's say we were to try 15. So I look at the x's. Well, first I look and see if I add down if something will cancel, but it doesn't. So I look at my x's. Can I times 2 by a whole number to get 5? Does that work? Does 2 times something equal 5 that isn't a decimal? Nope. Okay, but I know there's a 1 in front of this y. So if this is 3, what do I want this top equation to say here? Negative 3. And since that's a 1, I'm going to multiply that top one by negative 3. Because again, when I multiply that all the way through, so negative 3 times 2 is negative 6, negative 3 times 1 is negative 3, and 0 times anything is still 0. And I leave this bottom one alone, this time my y's are opposites and cancel. Negative 6 plus 5 is a negative 1x. 0 plus 2 is 2. Because again, once I get that multiplying done, I'm adding. The signs may be a little different, but I'm still adding. And then I got one step to to get my x. And again, keep this simple. I'm going to keep using the top one. 2 times x, my x is -2, plus y equals 0. So let's see, that'd be -4 plus y equals 0. At least there's no number in front of y. It's still only going to be one step. How do I get that -4 out of there? Just add it. So y is 4. Okay, but I always have to get 2 variables solved for on these. So always try to add down first. I think like the first 4 in this section, 9, 10, 11, and 12, you can just add down. And then the last 4 we got to play with a little bit to make those work. And I think all we got left are the word problems now. Yep. Now, notice on this page, it says, set up, but do not solve. So, let's see. Paul makes 12 baskets during the game. Some of his baskets were 2 points, some were 3. In total, Paul scores 29 points. How many of each type basket did he make? Now again, some of you may choose you just want to use x and y for everything. Because here, having a number kind of makes this tricky. So here, maybe I call x my 2-point baskets. And y my 3-pointers. If you come up with some other way you'd like to do that, that's okay. And then again, here, I've got, all right, so let's see. What numbers haven't I used yet? I got 12 baskets, I got 29 points. So, my first one goes back to, well, my number of 2-point baskets, okay, plus my number of 3-point baskets. So this is kind of my baskets equation. How many baskets did I make? 12. Okay, so my first equation is nothing but number of 2-point baskets, number of 3-point baskets, and the total. My second equation here ends up being my points. Well, duh here. I know it's going to be a duh moment. How many points is a 2-point basket worth? Well, 2. Plus the number of points a 3-point basket is worth times the number of baskets there are equals the total number of points I scored. And again, that's all you have to do here. Okay, don't have to do any solving for anything. Now let's use that kind of as our key and see if we can knock out number 18.
So you're just kind of setting the problem?
We're just setting up the problems in this section. So let's see, the Chess Club's having a spaghetti dinner as a fundraiser. 50 people attend. Adults pay $7, students pay $5. At the end of the night, the Chess Club has $310. How many students and adults attended? Okay. What are my 2 different things? What are going to be my 2 different variables this time? Okay, adults and students. So this time, maybe we can actually use the letters. If you just want to keep using x and y, you can, though. So we got some adults, we got some students. So here, we've got 2 equations. We have people, and we've got money. So let's see. We got us some adults, got us some students. How many people came to this? 50. Okay, so the first part's nothing but people. Adults plus students equals total number of people. Now we bring money into the game. What's going to go with my adults, my A? How much is an adult?
50. Wait.
7, okay. So 7 adults. What about our students?
50.
How much does a student cost?
Keep it on the people.
Okay, $5. And how much money did they raise?
350.
because all of my money numbers go in that second equation. And then 19 will set up real similarly. But again, this page we're just setting up. That's it.
The
No,
next page, the last page,
yep, the last one we're going to start doing some solving. So as we flip over here, one last flip. Now we get to solve. So we will do 20 and 21. Then I will let you loose here a little bit, or we'll see if there's others we want to go back and hit. Hey, we were doing these yesterday. The sum of two numbers. Again, when we see two numbers, that's just x and y. What's sum mean again?
Oh, plus.
Plus. So the sum of two numbers is 20. What's the difference? Minus. The difference of the same two numbers is 6. Nice thing about these, go to add down, you're always going to have a variable cancel. Y is see you later. 1x and another 1x is 2x. 20 plus 6 is 26. And then just divide. We wish they would all go this quickly. And then again, in this case, a lot of you will probably be able to do the second one in your head, but if you're kind of like, nah, I'll make sure. We're just going to take this first equation. 13 is going in where x went. Plus y equals 20. And then I'm going to minus the 13. Because 13 plus 7 is 20, 13 minus 7 is 6. But even if you can figure out off the top of your head, set the equations up. Because again, it's getting practice for some of the other ones. So be careful, be careful, be careful. Oh, and finally, bump this up a little bit here. All right, I'm going to go to the store and buy pop chips for a party. Pop is P, chips is C. I even help out there. Pop's going to cost $2 for a 2-liter. Holy cow. And chips are $3 a bag. All right. This is like what we were setting up on the last page. Equation 1 is my totals. So my pop plus my chips. How many total 2 liters and bags of chips did I purchase? 16. Okay, equation 2 gets to the costs. Now money starts coming into play. How much did I spend for each 2-liter of pop? 2. Okay, spent 2, so 2 times P. How much did I spend for each bag of chips? 3. I agree. I know. I don't know where they're going. Maybe it's down to the gas station or something. They overcharge sometimes. It's $38. We do. Because if I add down this time, I don't get rid of P or C like I did in the last one. So now, what am I going to be multiplying by? Okay? If I want to get rid of P, if this is 2, I'd like this to be negative 2. Well, all I have to do to make that a reality is multiply the top one by negative 2. If you'd have wanted to get rid of C, you could have just done negative 3. All the way through. So that C will become negative 2C. And negative 2 times 16 is negative 32. Leave the bottom one alone. And a couple of nice things happen this time. Negative 2 and positive 2 cancel. Negative 2 plus 3 is just C. And negative 32 and 6. Sweet. I don't even have to do anything else. I just get C. And then again, it's about simplicity. If I use the top equation now to figure out P plus C, which I know is 6, equals 16. I got a one-stepper and I'm done. It's nice. And I'm done. So like I said, tomorrow we are going to be doing a game, okay, that'll let you get some more practice with this, or if you need to be finishing up something with one of the other worksheets, because there's 4 assignments in all that we've done since the last quiz. I've got them listed on the back board. Those are the ones that are due by Friday when we actually do the test that'll look like this. So tomorrow you'll have a choice between working on that or playing the game, however you want to work it, kind of see how it works. This